So here we have one of BrotherHobby's latest motors. This is the Tornado T3 2306 2450 kV. This is brand new. I was quite surprised to get it sent. Wasn't aware that they were gonna release something like this, but it was quite a pleasant surprise. So as usual, the motor comes in this pretty simple boxes, which is not bad. Keep the cost down. And they do give you 4 M3 by 8 screws for mounting the motor, and now they're including a low profile aluminum nylock, so that's pretty good. This will save a little bit of weight, so every little bit counts. So here it is, as you saw it on my video preview. So finally I got around to testing it. So pretty interesting looking motor. They're going with the naked bottom now on the Tornado series. So of course that's done to save weight, as these motors are getting larger in stator diameter. So they're trying to cut down weight any which way they can to keep them, to stay competitive. Also, this is like the latest trend. Everybody's doing this type of motors lately. The rest of the motor is pretty similar to the T1 and T2 series. The here's the familiar fins for cooling. The other one thing they did change is they went to a solid one-piece shaft, which is it's hollowed. That's different now on the T3. So the shaft is hollow all the way through. So the Tornado series is pretty much packed with all the features that you can think of on the premium series of the motors. This one has, I believe this is titanium shaft now, and curved magnets, and pretty tight air gap, and pretty dense on the magnets. So as you can see, the magnet density is quite high. There's hardly any gap in between magnets, and they are pretty thick, pretty chunky magnets. They're also using the shaft retaining screw, and seems like that they're used pretty strong thread lock, and quite a lot of it. So if you're gonna disassemble this, I do recommend the technique I started using on DYS a few months ago, where I would use my iron, my soldering iron, and just leave it there for like, I don't know, like 5-10 minutes or so. And what that would do is it would loosen, it would kind of melt and loosen the thread lock, and then you're able to remove to loosen the screw without messing it up, because they're using pretty strong thread lock. So if you're gonna do that, I highly recommend that, so you don't mess up the screw. I was when I removed the screw on this one, I thought it was gonna be as easy as on the R5. So, but this one, they seem to use more thread lock on this one, so it was kind of hard. So I ended up having to heat it up, and then I removed it, but it was pretty hard. So here's the screw. So good idea to heat it up before you remove it. You can see there's quite a lot of thread lock there. Alright, so let's weigh this motor and see what it weighs. And that's gonna be with 160 millimeters of gauge, 20 gauge wire. So So that's gonna add to the weight. So with the wire, 35 grams with that much wire. So if we remove 330 millimeters worth of wire, that would leave about 50 millimeters of wire. Um, so let's say you were to shorten it by 330, so that would save 2.6 grams. So 35 minus 2.6, that's 32.4. So 32.4 grams, that's what it weighs with 50 millimeters worth of wire. So not the lightest, but not too bad. It's actually a pretty good weight, considering it's got this really chunky magnets. I think a lot of the weight is coming from those magnets. So now let's take it apart and check it out under the magnifying glass. Alright, so here it is under the magnifying glass. You can see the pretty tight air gap and pretty chunky magnets. And there's the shaft retaining screw. Looks to be quite beefy, but still, if you just try to remove it, even with a good Allen key, you might end up camming or messing up the head, rounding the head. So I really recommend that you apply heat with the soldering iron to soften the thread lock, so you can easily loosen the shaft and remove it, the shaft screw, and remove it. So I found out the hard way. I had to heat it up after the fact, and it was pretty hard to remove. So you can see, comes with a lot of they're using a lot of thread lock on this, and it's pretty strong. It's not like the purple one that's easily removed. They're using like a really hard one. Alright, so once that's removed, you can pull this apart. It's pretty strong magnet, so you have to really pull hard. And there's the what we're familiar with these the fins on the bell, which help move air through the motor and keep it cool, which works pretty well. These motors run fairly cool, and there you can see the pretty high density on the magnets. There's hardly any gap in between poles, and they're pretty beefy, pretty chunky. So this motor, I'm thinking it'll have quite a bit of torque. So we'll see how it does on the test compared to the other motors. And here's the stator. They're still using single wire strand, it looks like, and the laminations look pretty darn thin, so they're probably 0.15. I really can't measure this, so let's see what the stator is. Stator height, yeah, 6 millimeters, so no surprises there. And the bearing, it looks like their BrotherHobby went to 8 millimeters diameter bearing, so it's a 4 by 8 by 3, 4 millimeters on the shaft, 8 millimeter outside diameter, and 3 millimeter depth on the bearing. So hopefully this become easy to find, because most of the other motors were using 4x9x4, and those were pretty easy to find. But we'll see how these are, how easy these are to source. So pretty well made motor, as we come to expect from BrotherHobby. So let's put it together and put it on a truss stand, and let's see what this can do. So here are the results for the thrust test of the BrotherHobby T3, the new motor from BrotherHobby, 2306, 2450 kV. The motor measured at 2470 kV, so pretty close to the specified kV value. And as usual, I tested several props, the usual props, some 5-inch and a couple of 6-inch on 3S, 4S, and 5S. As we can see, some pretty good numbers for this kV value, and the motor seems to be fairly efficient. It does break the 1500 grams with the heavier 5-inch props, the Lumineer and the 5045 by 3V2 and the Dow Cyclone. And with the 6-inch props, it got somewhat close to 2 kilograms, not quite there. I imagine if the kV was a little bit higher, it would definitely break the 2 kilogram mark. As we can see, the motor has a lot of torque. It just keeps making thrust, and the amp increase is pretty gradual, so I'm not seeing any drastic jump when we go from 5-inch props to 6-inch. So that's a good indication. The motor has good torque. On 5S, with this 5040 by 3 prop, the motor almost broke the 2 kilogram mark, and a pretty decent amps. Again, remember that these are static thrust, so the amps are gonna be quite exaggerated. Once you're in the air, these are gonna be much lower. These are momentary max numbers. That's what I usually use in my tables. So it's a little bit exaggerated. You just
usually I just say to people to multiply these max numbers by around 0.7, 0.65, and you'll get your max numbers for in-flight amps. And those are going to be maxes too, so it doesn't mean you're going to be uh, seeing those numbers all the time. Remember that when we were flying, we only do 100% throttle for very short bursts, and even in those occasions, the max is just gonna be momentary, maybe for a second or two, and then it's gonna drop off, even if you keep the throttle at 100%, because the props will unload as the copter gains speed. The airstream is gonna be going faster relative to the prop, so the prop is gonna unload. It's not gonna be able to grab as much air, so it's not gonna load as much. So the amps are gonna drop off as soon as you gain speed. So the maxes usually you see them when you do an abrupt 180-degree turn and you hit the throttle 100%, or you're coming out of a dive. You're diving and then you of course wanna go 100% throttle and to get out of the dive. So in those occasions is when we're seeing the max amps. Other than when you crash in a branch and the FC is trying to adjust itself, and it may spin one motor, apply a high load to one motor. So those are gonna be also pretty high numbers there, but that's in a crash. So anyway, these are the numbers, and hope you find this data useful. You can compare this with the other motors I've tested of the same size and similar kV. So that would be useful to compare them. This motor does do pretty well compared to the other motors of this in this class. It should be right up there on the list. So pretty good offering from BrotherHobby. So now let's see what people do with this motor, and let's see how it does with the abuse that we're gonna put it through. So hopefully it looks like it'll be as sturdy as the T2 motors, the T2 2206 motors, which are pretty sturdy motors. They take a beating and run pretty cool. So this one seems to be following on the same design philosophy. So okay, thanks for watching, and until the next video.